we are talking about the chain rule. So, what do we remember about the chain rule?
Oh, it's like
The derivative of the outside function composed with the inside function multiplied by the derivative of the inside function. Okay, we remember that now? All right, so let's start with an example for today. Let's do let's do f of x equals the square root of 8x squared plus 5x. So, what we want to do is identify the inside and the outside function. So, the outside function, or what's the inside function? What's on the inside?
8x squared plus 5x.
Yeah, so 8x squared plus 5x. And what's the derivative of that?
8x plus
16x plus 5. So then looking at f of x would be the square root of x. So the derivative of that, which that is x to the 1/2. So the derivative of that is 1/2 x to the negative 1/2. So when I'm looking at finding the derivative, I want to take the derivative of f and put parentheses where the x is. And then inside of the parentheses, I put the g of x. So that is 8x squared plus 5x. And then, by definition, we multiply by the derivative of the inside function, which is 16x plus 5. So this negative 1/2 tells me that I can put this 8x squared plus 5x in the denominator. This 2 also is going to go in the denominator. And then 16x plus 5 is in the numerator. Okay? So, let's look at another example. Maybe. All right, example 2. Let's do Okay, so we have this to the 7th power. So we need to identify the outside function and find its derivative. Then we need to identify the inside function and find its derivative. So what's inside? Yes, the trinomial. And then the derivative of that would become 6x plus 5 because the derivative of a constant is 0. So now the outside function is x squared. And so the derivative of that is just 2x. No, x to the 7th. That's to the 7th. So that's going to become 7x to the 6th. I'm just making stuff up. X to the 7th, because that's a 7. So the derivative is 7x to the 6th. So when we take the derivative, we start with the derivative of the outside function. But where there is an x, we put parentheses because we're going to compose it with the inside function. And then multiply it by 6x plus 5. Now, definitely don't expect you to take this out to the 6th power. But something we can do is take 7 and distribute it into this. So that would become 7 times 6. What is 7 times 6? And then that would multiply with 3x squared plus 5x plus 2. You cannot put the 7 into this group because it has the exponent. So this is what I was talking about why one thing that's taking a little longer with the test is because like some people, may have stopped at this point. Now, obviously, you didn't have this on the test. But there's different places, like everyone took their problems to a different level. So I'm having to just make sure every step, is correct. I'm trying to really go through it thoroughly. All right, so now let's look at an example that has some trig. So let's do f of x equals sine 3x squared plus x. So we need to identify f of x, which is the outside, identify the inside, and then find the derivative of each. So what would we say is the inside of the composition? 3x squared plus x. So the outside is sine x. Okay? So what is the derivative of sine? Cosine. The derivative of this binomial would become 6x plus 1. So the chain rule says we take the derivative of f And wherever there's an x, you put parentheses and input g of x. And then you multiply it by the derivative of g, or of the inside. And you could leave it like that. Another way you could write it, I mean, there's not a lot of ways you can write it. You could write it 6x times cosine plus 1 times that is, so I'm showing you like different ways you could write that. All I did here was take this pretty much and distribute it, and that's how I got this last part. Just some different ways. Okay, let's look at, what number is this? Example 4. So last class we looked at none with trig. So today I want us to look at several with trig. So if we have uppercase f of x is equal, let's do 2x cubed plus cosine x to the power of 50. What? But the 50 is really not going, I mean, it's a big number, but it's not going to make it any more difficult. So, again, y'all know I like to do my side work. I need to identify the outside, the inside, and then find their derivatives. Okay, so what is the outside, or what is the inside function?
2x cubed
Plus cosine, yep. So, if that's the inside, the outside is just x to the 50th, so its derivative is 50x to the 49th. Now, the derivative of g of x, of the inside. So we look, what's the derivative of 2x cubed? 6x squared. And what's the derivative of cosine? Okay? So, we want to find the derivative. Remember notation, when you start finding the derivative, you need to note that. So, it is the derivative of the outside. So, 50, put your parentheses to the 49th. And what's going to go inside my parentheses? The g of x. So 2x cubed plus cosine x. And all of this is going to be multiplied by the derivative. And because we're multiplying it all by the derivative, put the derivative in parentheses, okay? And you could leave it like this. You could distribute the 50 through here, I'll say it doesn't really simplify anything when you distribute it. But you can. That would become 50 over 6x squared minus 50 sine x.
Over 6?
Oh, no. Thank you. Not 50 over 6. That is not a 1/6. It would be 50 times 6, which is 300. So let me show you what I'm saying. This, you would say, you could distribute here. So 300x squared minus 50 sine x. But that still is going to be in parentheses. So see how it doesn't really it doesn't really do much in terms of kind of.
Because like if you foiled it, then it would like simplify if you're going to.
But you would have to
I know, like,
you have to do that to the 40. You would have to multiply that 48 times.
Yeah, but like if you're gonna
if you were gonna do it. Yes, that is true. Less to type. Also, another thing you could have rewritten this. You could have had. I'm not going to write it, but I'll say it. You could have had 50 and then parentheses this, and then the order doesn't matter. It's commutative. It's multiplication. So what I'm saying is, like, don't get so if you get an answer and the order's different, it doesn't mean you're wrong. You might just have ordered it different. Multiplication is commutative. Okay, now let's look at one with a secant. So let's say we have f of x equals secant to the 1 minus 5x. So our outside function would be secant x. Our inside function is 1 minus 5x. So, we need to find the derivatives. What's the derivative of secant? Look at you. Yeah.
Oh, is that right?
You were just guessing?
No, I thought that's what it sounded right.
Yeah.
I think I have really good like subconscious answers. Or
Like-
I don't know it, but I do.
Like,
it's in the back of my head.
and so,
like,
like,
I know the
sometimes
answer,
people-
but I don't actually know it.
like you just think it. You're not confident in it, but. And that would be a -5. If I wasn't recording, I would tell you a story right now.
Kendrick probably loved this story.
Kendrick is like,
I know she
he
will.
looked at me. I was like,
She-
yes,
she'll be
record.
watching it, she'll be like, tell the story.
She's like, he's probably like, record every class. Y'all probably get out so much earlier if I didn't have stories. I want to make your drive here worth it, though. All right. Anyway,
What's the story?
I don't even remember. So here is what we want to pay attention to. Anywhere there's an X, you put parentheses. We haven't done one like this yet. I need to write smaller so this all fits. So what I'm saying is, in the past, the last like 3 problems we did, we only had one X in the derivative, but in this one there's 2. So we're going to have to input into both of those X's. So secant, parentheses, tangent, parentheses. And that's going to be multiplied by the derivative, which is just -5. But inside the parentheses is where we put our g of x. So now, really the only thing to do, I mean, you could leave it like this, but it's cleaner if we put the -5 in front as like a coefficient. And that would be our answer. It cleans up not having to have so many parentheses. Okay. So now this next one we're going to look at, I think we can do it all on this page. So this is example what, 6? Example 6. I'll just write smaller. Say we have f of x. That was a little screechy. All right, f of x is cosine 4x plus cosine. Okay, this is gonna be fun. Hold on, let me get my pen working. So, in this one, we have 2 chain rules in one problem. How fun is that? I don't see everyone looking so excited. What I mean is, isn't this cosine to the 4th x, that's cosine x to the 4th, that's a composition. But then cosine composed with x to the 4th is also a composition. So we're going to have to apply the chain rule here, which I'll call this chain rule 1, and chain rule 2. Kind of like, thing 1 and thing 2. So, to take the derivative, we're going to start, we're all obviously going to put all of this together, but let's think about cosine. Let's think about what this means. This, if my pen works, this is equal to this. Okay? Now, if I want to start here, what would the inside function for this be? The inside is cosine x, and the outside is x to the 4th. So, the derivative here would be 4x cubed. And what is the derivative of cosine? So, as we are doing this part, chain rule 1, that's going to become the derivative of f composed with g of x, which is cosine x, multiplied by negative sine x. Then I'm going to have a big plus sign here. I mean, it doesn't have to be any bigger than usual. I just put a plus sign here. And we're going to do the chain rule for this. So now, before I do the chain rule for that, I want to look at how can I simplify this. We could write this -4 sine x cosine x, cosine cubed x, like that. Okay? Does everyone see what I just did there? I just rewrote. I put the 4, I put the negative in the front, just kind of rearranged it. I rewrote that cosine x cubed as cosine cubed x, and it's a little jumbled, so I'm going to just kind of clean it up a little bit. So now I want to do the chain rule for cosine x to the 4th. So looking at that, we want to identify the inside and the outside function. So your inside in this one is x to the 4th, and your outside, so this is opposite of what we just did. So the derivative of f is negative sine, and the derivative of g is 4x cubed. So when I put that in here, applying the chain rule, that would be negative sine, and in place of x, we put the x to the 4th, and then you multiply it by the derivative of the inside function. So now as I go clean this part up, this plus a minus, this plus and this negative means I can just put a minus here. And then this, I would put minus 4x cubed sine x to the 4th. So this was like doing 2 problems in one. Alright, let me give you one to try. Do you want one with trig or without? With? This is like, I don't care, just throw it at me. Alright, let's start a new page. Oh, my. Alright.
You notice how it's like still there?
On the, is it?
Like it's not, but like, I can see it. See it outside.
See, it's not on my screen though, so
I
it
think
must,
it's still protected. And
anyway.
it's like burned into the I mean, I think it goes away after a while.
Alright, so let me make us a problem. Let's do, let's do maybe 5x to the 4th plus sine x, and let's take all of this to the 20th, third power. Because why not? It's better than the 50th, right?
How do you multiply 24?
Anyway. So the inside function is 5x to the 4th plus sine x. And then that means the outside function, sorry, my brain, and is x to the 23rd. So the derivative is 23x to the 22nd, and the derivative is 20x cubed plus the derivative of sine is cosine. So we take the derivative of f, and that's going to be 23 parentheses 22. Inside the parentheses, you put the g of x, and you multiply that by 20x cubed plus cosine x. And if you leave it like that, that is fine. Or you could do what? Distribute the 23 with this, and that would become 460 x cubed plus 23 cosine x times 5x to the 4th plus sine x to the 22nd power. How did you guys do on that?
I didn't distribute
Because just multiplying by 23 was just out of the question, right? I know, you told me.
Okay, but I had like.
You forewarned me. I understand.
No, I did mine different.
Oh, what'd you do?
I did like, I distributed the 5x to the 4 plus sine x to the 22. Like, so it's 460x cubed plus 23 times cosine.
You can't do that.
I can't do that.
So tell me what you just said. Hold on.
We did it for the other one.
So tell me what is raised to the 22nd power on your paper.
The 5x.
Okay, so you have 5x to the 4th plus sine x to the 22nd. Tell me,
No. That's not what
you have what?
I don't know how to say it.
You don't want to say
I
it?
don't know how to say
What does she have on her paper?
Okay.
I just
460x cubed, and then in parentheses 5x to the 4th plus sine x, and then in parentheses to the 22nd plus 23 cosine x, and then in parentheses 5x to the 4th plus sine x, and then in parentheses. But then we also
Let me look at it.
2. Like divided 2 is plus.
Here's the thing. This right here, is that in your problem somewhere, your final answer? And then is it only written once, or do you have that written twice? So you have 460x cubed times that plus 23 cosine x times that. That's correct. And why it's taking me so long to grade these tests. That is fine. Okay. I thought you put the 23 into this, which cannot be done. Okay, now I see what you did. Well, I don't see it, but I get it. So now, example 8. So I want us to look at one with an exponential and one with a natural log. So let's look at, say we have f of x is e2. Now all of this right here is an exponent. All of that's an exponent. Okay? We see that? Yes.
So I was never taught about the e or the natural log or anything like that. Could you go over it really quickly?
What about it?
Like, I don't know what it means,
Um,
and I don't know how to solve that or anything like that.
all right. So, one, I can make a note that we can go and I can do next class discuss e and natural log, like what they are. But for the sake, because we only have 9 minutes, I'm just going to talk about how to take the derivative of it today, and then we can talk more about what that means in terms of exponents, because that's what it that's when you use it. But the e is an irrational number, kind of like pi, but it's e to an exponent. We're thinking of e to the x. So we said in maybe last class or the class before, we just wrote the derivatives of them. So when we look at this, our inside and our outside function, our outside function is e to the x. And what is in place of the x is that trinomial. So the derivative of e to the x, we took a note on that the other day, is just e to the x. And then the derivative of that trinomial, you just get 4x cubed minus 6x, and the 9 goes away. So the derivative of e to the x is e to the x. And Monday, we'll talk about e to the x and natural log. I think Tiffany will be back Monday too, so it'll be good. Because I know did you take pre-cal, Krista?
Yeah.
Yeah? But y'all didn't talk about it much?
I did talk about it,
You
and
did?
I was just as confused.
Okay, okay.
I didn't learn it in high school.
Okay, so we can look at that again.
I didn't learn E in high school.
You did learn natural log though? Yeah.
But I don't remember. I just know it's on my calculator.
Okay. We can look at that Monday. So when we're looking at the derivative here, you will take the derivative of f, which is just e to the x, and anywhere there's an x, you put in what g of x is. And then multiply it by the derivative of the inside function. This is fine. I just, for me, I like to put my e at the end. And as long as you carefully write all of that exponent at the top, it doesn't really have to be in parentheses. Because unless you put in another base, obviously it always is the exponent. And that would be the derivative. So, natural log, we are going to look at, we talked about the derivative when we have a natural log is 1, we take the natural log and it becomes 1 over whatever your expression was. So we're going to look at applying the natural log for this last one. If we have the natural log x to the negative 4 plus x to the 4th. So identifying your outside and your inside function. Think of it like having sine here. The inside function is what's in parentheses. So the derivative of that is negative 4x to the negative 5th plus 4x cubed. Then for f of x, that is just the natural log of x. And the derivative of natural log is 1 over x. Okay, so now for the derivative, you take the derivative of f, and anywhere there is an x, you input g of x. And we're going to multiply that by the derivative. And then the only thing I would do here is I would slide the derivative of g into the numerator. Like that. And that's how I would leave it there.